In this experiment, we're asked to determine the excess charge that's needed to float one tape above another tape. To do this, we have to create two charged tapes by putting a base tape on a flat surface and ripping another piece off. We can assume that these tapes will have the same charge since they're created in the same manner, so that we can just assume straight from the beginning. And we also will find that both tapes are negative, which I performed by rubbing a plastic pin through my hair, which gained an electric charge, and comparing it with the tapes. And the tapes repelled this pin, therefore I know that's negative because like charges repel. I also determined that the excess charge needed was a negative number, which makes sense because these tapes will be negative, so therefore they need excess amount for the tape to float. If it was positive, then potentially the tape would be attracted. Some assumptions that we make in this is that each tape is one charge concentrated at a specific point, which allows us to be able to treat these tapes as point particles rather than looking at the whole tape. Another key concept is the momentum principle, which is from Physics 1. We can also assume here in our calculations that the particle of the floating tape is motionless, therefore F net equals 0. So then we can break down the net force into its individual forces, which will be helpful in later calculations. So gravitational force and electric force are the only two forces acting. And we know what the gravitational force is by measuring the mass of the tape. So since we know the mass of the tape, we know the gravitational force, then do some simple algebra to figure out electric force after we've had it set equal to 0. So now that we know what the electric force is, we can then plug that into the electric force, or Coulomb's law, equation. So electric force equals Q times electric field. Now we don't actually know what the electric field here is, because that would require us to know already what the amount of excess charge is. Since we don't know that, we have to break it further down into its components, which gives us K times Q divided by magnitude of R squared. Then, since we have Q in this equation, we can do some algebra to solve for Q. So here are some measurements that I made in my experiment. So I figured out the mass of the tape by measuring the distance of the tape and doing some conversions. I also have separation distance and the ratio of electrons to atoms, which I determined makes sense because there should be more electrons per atom in order for this tape to float. Here's my code. I define my constants in the first few lines. Also, particle 1 here is my top tape, particle 2 is my bottom tape. And then in line 22, you can see my equation solving for Q, which is where I did the algebra as I stated in one of the previous slides. My results here make sense for gravitational force because it should be negative because it's acting downwards on the top tape, which the Earth is acting on it. And the electric force makes sense because it's balancing out the gravitational force as we saw with the momentum principle. The charge needed to float the tape makes sense since it's negative, which shows that the excess charge would be negative, so more electrons. And then therefore excess electrons will be a positive number. In conclusion, if electrons had positive charge and protons had a negative charge, the same sort of observations would occur. The two tapes would still repel each other because although you're changing the charge that electrons have, both tapes would still have the same charge. So they would still be repelling each other. However, the calculations may have a different sign, but that's the only big change that would occur. Also, in doing this, it's important in making sure that you handle tapes as little as possible, because although we don't think of us having particles in our hand that affect the charge, however, we can neutralize the charge of the tapes with our hands because there are particles that are attracted to the tape.